Hi everyone. So in this case we're asked to solve this equation, but to give the answer in general. Notice there's no domain given to us. So with a question like this, you have to be told what mode you're supposed to be in, and this one tells us that we're doing this in radians. So there we go. So I've got this quadratic formula in cosine, and I'd rather not work with it like that. I'm going to just eliminate the cosine right now just by putting an x there. I don't know what the cosine of theta is, so it might as well be an x. So now I've just got this quadratic that I'll solve. So this will be 2x, x, 1, and 1. That'll have to be positive and a negative. So that tells me that my answer has to be x is equal to positive 1/2 or x is equal to negative 1. So now I can go back and say, okay, cosine of theta has to be 1/2 or the cosine of theta has to be negative 1. Now, let's look at each of these individually here. Now I'm going to have to speed this up a little bit because I'm running out of room here. Cosine is positive in quadrants 1 and 4. My reference angle here is going to be pi over 3, which means, okay, in my first quadrant, okay, I'm going to get pi over 3. Okay, so let's think about it like this. If you look at the full circle here, what we've just identified is I've got an angle here and an angle here. Now, that's pi over 3 all the way around. Okay, if I count this out here, there would be 3 up here, 3 pi over 3's here, and I'm losing 1, so that would be 5 pi over 3 to get me into the fourth quadrant. And those are both the angles coming out of that first factor here. Then I look at this, cosine of theta is equal to negative 1. Okay, now cosine fluctuates between negative 1 and 1. So this is kind of an extreme value for cosine. Cosine is related to the x-coordinate. Well, where does cosine go to negative 1? And the answer is out here on the negative x-axis. And so the answer for that is going to be pi. So cosine of 1/2 gets us pi over 3, 5 pi over 3. Cosine equaling the negative 1 gets us pi. Now, these angles here, because this is cosine, are all going to repeat every 2 pi radians. Okay, now I communicate every 2 pi radians by multiplying by n, but I have to restrict n. N can only be an integer value, and so we use z to represent the integers here. I don't want a fractional value, but I don't mind it being negative. It can be negative whole values there, okay? So that's how we communicate the general solution for this particular problem.